So we've talked a lot about how to use Spack as a user, both the basic hands-on that I started with and the configuration, more advanced options. But now we're going to talk a little bit about how to make your own Spack packages. If you develop software that you want to deploy to people, or the person whose software you want to deploy to yourself hasn't packaged theirs and you need to do it for them, how can you make your own Spack packages? So the package is basically a recipe for building. It's a Python class, and it's got some metadata about the package, dependency information, version information, etc. And then it's got a templated install method. And that method takes the spec, this is the concrete spec after concretization, takes the concrete spec as an input parameter. So all of the crazy stuff you do with configure scripts or CMake where you're trying to find your dependencies, you don't have to do any of that inside of a Spack package. You know where everything is. And then it often looks pretty simple like this. Sometimes it looks more complicated. It's Python. It's Turing complete. You can do whatever you want.
Are the hashes MD5 or SHA-2?
We use SHA-256 by default now. A lot of the packages have leftover MD5 checksums from when that was the default. So if they don't say anything, they're MD5.
Well, no, if they don't say anything, the algorithm's detected based on the length of the hash. Okay.
If they don't say anything, they were probably MD5.
Yeah.
And then package collections are repos. We talked about that earlier, or Todd talked about that in the basic concept section. But you can see this is within some repo, under packages, the package name, and then you've got the recipe. So I talked a little bit about the fact that these are templates, not instantiations of the build recipe. Each package has one class. We don't have separate classes for any different options. Each version, each configuration occurs from the same class. And you can add conditional logic using the spec syntax. So we can say if tilde shared in the spec, do one thing, otherwise do the opposite, turn it off, turn it on. But we use this spec syntax based on the concrete spec we've gotten to instantiate that template within the install method. I also mentioned earlier we have compiler wrappers. That handles a lot of the details for us. We don't have to construct -L, -rpath, -WL, rpath options in here. We can just worry about the basic logic. The compiler will handle, the compiler wrappers will handle the linking for us. So what does that look like? Here's kind of what happens when we say Spack install HDF5. We call HDF5's do install. What does that do? It recursively calls do install on each of the dependencies for each thing that and then it installs itself. For each thing that it installs, we fork a process, set up the build environment. That allows us to sanitize the environment without blowing away your user environment after the command's done. So we can unset variables like path and LD library path. Then we call the install method. That does whatever it happens to do. But we've got these compiler wrappers that then will intercept and add the flags. So that's what's going on under the hood when we do this. So what actually goes in the package? I mentioned there's a bunch of metadata at the top. So we've got the home page for the package, the URL. And you'll notice this is the URL to some version. And then we've got the other versions. Spack knows how to take this version, say, okay, there's a version in here, it's one of these, and then start substituting the other ones in to look for the other things. When that doesn't work, there are ways to override it. I mentioned the checksums SHA-256, and you can fetch from different sorts of version control instead of a URL also. You can have, instead of URL equals, you can have git equals, hg equals, whatever you need to get that package. The other sort of metadata that we have is metadata about the build. So the variants that we've talked about, do we want to build PETC with MPI? Default is true, you can turn it off. Different variants and different dependencies. And your dependencies can be just on the package name, if you prefer. Depends on BLAS. You can use the spec syntax to be specific about what you depend on as well. I depend on Python at 2.6:2.7. So remember, this slicing is inclusive on the top end. So either of those versions works. And then you can also have conditional dependencies. I depend on MPI when I'm built with MPI. And we're using anonymous specs here for the when clauses. The when clauses can also be Python Booleans, so you can check on various state of the system for a when clause also. And notice that these are two sort of standard dependencies, and here we've got a virtual dependency. We talked about those primarily with MPI, but we can specify them with exactly the same syntax.
Quick question.
Yep.
If it depends on either of two, Python 2 and 3, how to?
You could say, here you could just say Python if you don't care. And if it's anything past 2.6, you could say 2.6: and leave the top end unbound. But if it was, say, 2.7 or 3.3 and up, you could say 2.7, 3.3:. Yeah. So then the last piece is the actual build recipe. It's executed in a clean environment, so you don't have to worry about that. And we've got some wrappers for some common options, right? We stick configure, make, and make install functions into your module scope in Python for you, because everyone needs those, and so we just do it by default. But there's also functions, the same functions that we use to create those are available to the package to, create a tar function in there to untar something that comes tarred up, whatever it would happen to be. And like I said earlier, it's Python. You can do whatever you want.
How to distinguish between in-source, out-of-source build, and those things?
Create a new directory, and then hop into there and do it. This is done in source. So here's another sort of nice bit of syntactic sugar that exists in there. We are not going to be able to go over all of the things like this today, in part because there's too many of them. The best documentation for a lot of the things about the packages is just look at the packages that already exist. Look at a package that you know has a similar build system. Look at a package you think might have a similar build system. Grep around for the sort of thing you'd expect it to be, and you'll start to see sorts of idioms like this pop up. The last thing on here to talk about is this when directive. That's a way that you can swap out entire functions based on attributes of the spec. So in the case of Dynant, they changed their build system after version 8.1. So we've got this array slice, everything up to and including 8.1. We'll use this, fall through to using this install method. And we create new packages with the Spack create command. You give it a tarball, it will download that, checksum it, stick it in there as a version, and then give you some sort of boilerplate that you fill in the rest to make it a little easier to get all this metadata right. And it generates special boilerplate for the different build systems that we recognize. If it can't figure out what it is, it just generates a default package. For subsequent changes, you can use Spack edit package name, and that will open it up in your favorite editor, assuming that you've set the editor environment variable to your favorite editor. All right. Let's go play around with this. So let's create a package file. Now, we don't want to pollute our built-in repository of package files with the stuff that we're playing around with today. So we're going to create a new repo that'll have a higher precedence, and we'll play around in there. So Spack repo add. I am not on the VM. Let me SSH into the VM real quick. And assuming most people got logged out in the interim, we're going to source the setup script again to make sure that Spack's in our path. So now we'll do Spack repo add Spack root var Spack repos tutorial. So we didn't have to create our own repo for this. There is a Spack repo create command because we actually ship Spack with the tutorial repo there and ready for everything that we do. So now let's create a package. I'm going to copy this line because it's somewhat long. Spack create -t generic. That's telling it, actually don't help us out with what build system this is. Why am I doing that? Because with MPI leaks, Spack actually figures out too much of it, and this tutorial wouldn't be all that interesting. So we tell it not to help us out as much as it could. That's -t generic. We could say -t autotools, -t cmake for the different templates if it wasn't picking up a template we wanted it to use. And then we give it a tarball. It intuits the name and a version. We'll just grab one version, that's fine. And here we go. And I could start editing from here, or I could realize that it's opened in VI, and that's going to be an unpleasant experience for all of us if I'm working in VI. And change to Emacs, and then Spack edit MPI leaks. And now I've got the same file open again. So I'm going to remove some boilerplate. That from Spack import star is actually not necessary anymore. We used to need it. We've overloaded the importer to not need it anymore. So I'll save that, and the first thing we'll do is Spack install MPI leaks. And just to see what happens. We don't really expect it to work, and unsurprisingly, it doesn't yet. We haven't really done anything. Yes?
So what if I want to create like a variant of an existing, let's say, installation package? So you have, let's say, MPI leaks X and MPackage to MPackage to X. So if I want to create a repo for MPackage to X, should I create a separate repo or a variant of it? So what would you suggest?
You don't mean a repo, you mean the package file.
Yeah, package file, yes, sorry.
So we open MPI leaks. You can put in here, like spack.pkg.builtin.mpileaks.capital.mpileaks, and you would actually be importing, you would be extending the class of this other package, and you could extend it that way.
He's asking about something in the main line already.
Yeah, that's what I'm saying.
Oh, okay.
You've got MPI leaks in the main line. We've got this separate package for MPI leaks that we're building, and you can actually put the class path for that here and extend it. And that will allow you to then say, just overwrite one thing in it, and the rest would inherit from the built-in. That's what you're looking for, right?
Well, but if you're trying, for example, like Hari is, to add a new variant to mVapage 2 in the main line,
Then you should just
add the variant.
change the one in the main line and commit it back to Spack.
And what if I have like multiple versions, one building from like one where I build from source and the other one where I want to ship a binary. So would that make a difference or is it all the same?
That should be all the same. You just don't have to make sure that the version that you only want to ship from binary actually builds from source. But you just put it in as a version so that Spack will know when it looks at the binary that it can do that. You can look at packages like the Intel compiler for how that's been done.
Okay, thank you.
So, the first thing we're going to do for MPI leaks is we're going to fix the documentation. So, you can put in a description of the package, and you can put in its home page. I'll get rid of the fix me. There we go. Why do I do that? Well, because then we can do spec info MPI leaks. And we can see what we've said so far. We've given it a description, a home page. We haven't tagged it as any particular type of package. We've got versions, and we haven't given it any variants. It's just got the one install phase, no dependencies so far. But the next thing we'll do is let's add the dependencies. Back edit MPI leaks. And normally maybe we would have to go read their documentation to see what they depend on. But in this case, I happen to know they depend on MPI, adeptutils, and call path. So now, when we go to install MPI leaks, we're going to get those dependencies built first, just like we did with everything else we've built so far today. And we can see it's going out and downloading binaries for all of them. And we got to MPI leaks, and we still got the same error because we actually haven't provided an install method for MPI leaks itself yet. So what do we do when we're trying to build a Spack package and we're not really sure what's going on? We've got some helpful tools for debugging. So the first thing we can notice maybe is we haven't called configure. So let's start there. But it's still not going to work. configure error unable to locate adept utils installation. So, might be obvious, might not be. So we can see at the bottom here, Spack's given us the location of the build log. One thing we can do is we can look at that. And we see there's not really much more context. We've still got this error unable to locate adept utils installation. But the other thing that we can do to help debug builds is we can actually manually enter Spack's build environment, try things out, see what works, what doesn't, and then go back and put what works into our package file. So we've got the command spack build env MPI leaks, and it works kind of like the env utility that you might be used to from Linux. If we just say spack build env MPI leaks, we just get the environment dumped to our terminal. But we can put a command to execute there, and if we put bash, we'll get a terminal in that environment. Now, if the MPI leak spec had a space in it, we would have to put this little double dash symbol beforehand to know, hey, what comes afterwards is the command. So we can jump into that environment, and then we can say spack cd MPI leaks. The spack cd command has a bunch of options, but by default what it does is it jumps to the stage directory where something was building. You can use it to go to the install directory. You can use it to go to the home prefix for spack. But this is where we are. And so now if we run /configure, we should get exactly what happened when we ran it through spack. And that's what happens. We get error unable to locate adept utils installation. So we could run configure --help maybe to see what the options are. And we could see, oh, right, we need to tell it where adept utils and call path are to be able to build against them. So now we will exit the shell that we created. So now I'm back in my user environment, and I'll edit MPI leaks. And again, I'm going to copy and paste. So what do we do here? We've constructed the configure arguments with adept utils, and we splice in the prefix, the spec. We can subscript by the package name. There can only be one of each package in our spec, and we can get its prefix. Similarly for call path, and then self.spec.prefix. And actually, we don't need these self dots because we've got spec as an argument right here. Similarly, we don't need the prefix to be self.spec.prefix. We can just take the prefix from right there. But I'm going to leave it as it is for now, just because of stuff we might do later with this. Now this is actually everything we need to install MPI leaks. Spack install MPI leaks. Now just as a note, packages are namespaced. I don't know if you noticed when we added the tutorial repo, it said adding a repo with namespace tutorial. The built-in packages are namespaced built-in. If I wanted to install the built-in configuration of MPI leaks right now, I could say spack install built-in.mpi leaks, and I'd get the built-in MPI leaks, even though we've overridden it with this one. Similarly, I could specifically request tutorial.mpi leaks, but it's the highest priority scope, so it's what we're getting anyway. Now, why did I leave self.spec all over the place in the package when we've got the spec as an argument right here? And the reason is that if we hadn't used that -t generic argument earlier, Spack would have actually figured out that this is using AutoTools because it's got a configure script. It would have gone up here, it would have subclassed AutoTools package instead, which has an install method that calls configure, make install, and has a function configure args that you override to generate the arguments for configure. You can see here what that would look like. It also generates the prefix argument automatically. And we could just do that instead of all of this and be done. But instead, we're going to start adding variants. We got a working version of MPI leaks, but we didn't necessarily get the configuration of MPI leaks that we want. MPI leaks is a debugging tool, and it has an option for how much of a stack trace does it give you when you've reached a leak. And so we're going to add a variant for that. We're going to call it stack start, because that's what MPI leaks generally calls it. We're going to say the values have to be integers. Here, we could have several different things. We can have a list of values. So if you give it an iterable, it will check that it's one of those. If you give it a Python type, it will check that it is of that type. And if you give it a function, it will call that function and check that that function returns true for that value. So these are different ways that we can restrict the allowable values to a variant. We're going to set the default to 0, and then we have a description that's just useful for the Spack help to help you figure out what's going on. Then we're going to come down to the install method, and we've got to do something with this. So first, we're going to say stack start equals, we need to make sure it's an integer, self.spec.variance probably shouldn't need the integer around it, but that's what I've got in my script.
I think we fixed that.
And we're going to say, instead of calling configure with a bunch of arguments, we're going to construct some arguments for configure. Then if stack start, Python allows us to do comparisons on arbitrary types. So that's basically if it's not 0. The same thing for an integer. Then we're going to extend these arguments. And MPI leaks actually has separate arguments for the C stack start and the Fortran stack start. But we're making this package. We get to decide how to treat it. And we don't think people care about having those different. So we're going to make it one option, simplify things for people. Then we're going to configure, give it those arguments, splat it in. This is just Python syntax for dropping a list in as separate arguments. Configure, make install. There we go. Now we've got a variant on our package. We can test it out, saying spack install verbose MPI leaks stack start equals 4. Now this verbose option is easy to forget, and we mentioned earlier, if you forget to put the verbose option on, you can just hit the V key to toggle it on and off during the build. So we go get the dependencies. We start calling configure. I'm going to stop the verbosity now. But if we scroll up to the top here, we can see that we added these stack start arguments to our configure line. Configure was running. I eventually stopped it from verbose mode, so it stopped printing its output. Finished installing, and it's installed. That's all the basics of a package. Yes?
Can we talk a little bit about error handling?
Sure.
So for example, you explicitly try to parse the user input as an int, which
Yeah.
will throw if it's not convertible. So where do these exceptions go if you throw outside of your...
So a couple things. One, I've already guaranteed that it's an int here, so I probably shouldn't even be making that call. But two, so this would error at concretization time. If we said spec MPI leaks stack start equals foo, stack start, not stack tart. So it'll tell us we have the wrong type. But then if it actually errors during the install method, we'll get an error like this. Right, we saw this earlier. It called configure, something happened, etc. Now, if this happened from within the Python itself, the calling context would be the Python that it errored in instead of being the build log. So you'd see actually part of your package file spit out here with the error line highlighted in red, same as it happened for the calling context inside of configure.
Okay, so what about user-defined, or rather, inside of your package file, if let's say the user enters 12
Yeah.
as a value here, but the only valid values are 1 through 6.
Well, so if you put that in the, if you actually put that in the variant,
Oh, so the variant can handle this?
can handle that, yeah.
Okay.
But if you didn't, and it threw, it catches all types. Any throw from within the child process is caught, returns a child process error, and it packages it up like this with the calling context, etc.
Do spec info box lib really quick to demonstrate that. So you can look at dim.
Yeah. So the dimensions, we've specifically said, has to be 1, 2, or 3.
Boxlib will not do 14-dimensional AMR. Okay. And so, like, if you type spec.
What you've got,
Boxlib
you just give it an iterable for the values. If it's not one of those values, it's going to have a problem. Now notice, these values are the strings 1, 2, and 3.
So depending on the package, they may or may not have done this in a good way, but it's okay. So you can, so even if you have like try spec boxlib dim equal 14.
But then if you say 1, it goes fine. Other questions so far? There's a bunch of stuff we can do with the spec object that we didn't have to do for what we did in this tutorial. So some things that we can do. We can check whether a spec satisfies a particular constraint. So this is saying if I'm at version 1.1 or greater, do some things. If I'm building with OpenMPI, if the thing satisfying my dependency on MPI has the name OpenMPI, do OpenMPI specific things. Anything you can specify on the command line, you can put in the satisfies. Am I using a GCC earlier or including 500? Do I have a debug variant on? You can also specify those things about your dependencies, the same way that the command line syntax telescopes this satisfaction syntax can too.
Are those automatically lowercase for you, or can you assume case?
All Spack packages are lowercase. We do not allow packages to be committed that are not lowercase, and if they are multi-word, they are separated by dashes, not underscores.
So all variants are lowercase, so plus debug.
For variants, you have to know, right, this is a variant in your own package.
Okay, so you should probably lowercase that.
You should probably lowercase it. I think we actually have contribution guidelines that require it to be lowercase, separated by underscores.
Well, but the user could put whatever they want on the command.
The user could put whatever they want on the command line, but it's going to say there's no variant.
Okay.
Spack, MPI leak.
Case insensitive, true.